We're going to look at solving logarithmic equations. Yesterday we solved exponentials. Today it's going to have a very similar feel, so make sure you see what we're doing, because remember, the inverse of logarithms are exponentials. One thing I want to reemphasize as well is, remember, the common log, the base 10, is just the common log button on your calculator. And if we have Euler's number, remember that is the inverse, it's not equal to, it is the inverse of natural log. So we will be using E to get rid of ln today, and we will be using a base 10 to get rid of just a log with no subscript number. We're just going to jump into the examples. You should see these on Delta Math. There's actually multiple ways that we can do the logarithms. I'm going to show you both, and then we'll, at some point, you need to break off and decide which way you want to do it. So one thing we can do is what we did a couple of lessons ago, and that is the conversion. We can convert this to 10 squared equals x. 10 squared is 100. So that is option number one. That's option number one. Certain questions it's easier, some it's a little more difficult. But what we're going to talk about today is getting rid of the logarithm. So this is log base 10. Again, this could have been written as just common log, but to get rid of log base 10, we use a base 10. We use a base 10 on both sides, and whatever way you do it, obviously you're going to get the same answer. 10 to the second power is still 100. I don't care which way you do it. To be honest with you, I like to match up the log base because it works on all sorts of questions. You don't have to convert, and some of these you'll see the spiraling that you do with it is not going to work out so well for you. Here's another option where spiraling is not really a very good move at all, to be honest with you, because the x is already isolated on this particular question. So since the x is already isolated, we can just simply put our log base into our calculator and get whatever the result is. So I'm going to, again, if you've forgotten, under alpha window, write this up here for you one more time, the alpha button, followed by the window button, and then option number 5 is our log base. So this particular one has a log base of 2 on the number 256, and that is just simply 8. And you'll learn as these go kind of which method you're going to want to do. Obviously, if the x is set by itself there, you're going to want to just simply calculate, put it in your calculator, and get an answer. So now we're going to surround the logarithm with a few extra steps. And just like yesterday, we're going to isolate the log and the log base before we try to eliminate it. So in this case, we have the multiplication of a -2 happening. So we're going to need to take care of that first. So what I do is I divide both sides by -2. So -2 divided by -2 goes away, and we have log base 4 n minus 5 equals -1. So once we've done that, what we can do, and by the way, tomorrow we'll talk about, I'm not going to give you any that have restrictions on the domain, but we do need to be aware of that they do exist. And we'll take that and run with that tomorrow. We've got to make sure that we keep this number from being negative. So for now, though, we're just going to work on the mechanics of solving. So the way I get rid of a log base 4 is with a base 4. What I do to one side, I have to do to the other. So my log base 4 cancels my base 4. So now I have the n minus 5 on this side. And this is 4 to the negative 1 power. So remember, what a negative 1 power does is it flips this number. So 4 to a negative 1 power is equal to 1 over 4. So that's where we are here. We are at n minus 5 is equal to 1/4. So we need to move the 5 over. And n is equal to 5 and 1/4. And that was a value higher than 5, by the way. So that's what we got. This one, just like the last one, we have multiplication happening to the front of our equation. We've got to isolate the log base, and since we have a parentheses, all of this material that we see right here is part of the log base. So we need to isolate the log base. We do that by dividing by -6. So now the log base is isolated. Log base 9 on -10 n minus 5 equals -1. We take the base 9, which cancels. And just like on the last one, we have 9 to the -1 power. So 9 to the -1 power is equal to 1 over 9. We still got a few steps to go on this one. So we're going to add the 5 to both sides. And let's go ahead and work this one as a decimal answer. So we have 5 plus 1/9. 1/9, any number by the way, divided by 9 is itself repeated. So that is 5.1111. And we will then, and lastly, divide by -10. And we get n equal to -0.51 repeated. Remember, when you divide by 10, you're basically just moving the decimal place to the left 1 unit. It's like when you multiply, you move the decimal place 1 unit to the right. When you divide, you move it 1 decimal place to the left. And our last example. Again, we've got to make sure that this stays positive, the x, -x plus 6, so we know that we have a restriction on our domain there, so we need to keep this value lower than 6. So let's go ahead and see what we've got here. First thing I want to take care of is the -2. And again, don't try to add things that don't match. Those are not like terms. That is 9 times. So we cannot just combine those two terms. We can, however, add 2 to both sides. So now we have 9 log base 9. And by the way, that does not cancel. That is multiplication. The value that cancels is when we have a power. When we have a power is when those values cancel. Now this is all set equal to 0. That's not an issue. Actually, that's a good thing in most cases. So we have the 9. And again, let me just reemphasize, these are not going to cancel. It's not just the 9, it's the base 9. So this is not what we have going on here. So we are going to divide everything by 9. 0 divided by 9, of course, is 0. So we have log base 9 on negative x plus 6 equals 0. So we need to get rid of our log base 9, and we do that with a base 9. Left side, this is kind of easy to see what's going on here because log base meets a base, they cancel. What we have left is negative x plus 6. And then think about what we got on the right side here. 9 to a 0 power. Remember, anything to a 0 power is 1. Anything to a 0 power is 1. So I'm getting close to isolating my x. I subtract 6 from both sides. So negative x equals negative 5. So positive x equals positive 5. And we did keep this number below 6 like we said we were going to from the beginning. So you see the similarities that we have between a logarithm and an exponential function. Again, we'll do a little more talk about the restrictions on the domain, which we see here. But essentially, we're following the same practice. Just remember, if you take any number to a 0 power, it is 1. If you take a number to a negative power, it is the inverse of that number. And if you were to take the inverse of a fraction, they both get flipped. So keep these little rules in mind as we work through. All right, you will have a CAMI assignment on this one. Make sure you show your work, and good luck.